morning everyone and welcome back to our video lessons. Today we're going to be comparing rational numbers and discussing what they are and how they line up on a number line. So let's get started. Make note of this in your book. I know we talked about what rational numbers were earlier in this unit, but we want to go ahead and make sure you guys know it 100%. So here is something else you can copy down. Rational numbers can be positive or negative. Rational numbers include integers, fractions, mixed numbers, percents, terminating decimals, repeating decimals, etc. These numbers are all examples of rational numbers. 5/8, 0 and 46 hundredths, -9, 3 and 33 hundredths, 25, and 10%. Again, copy this into your notebook so you have a really good reference before we move on. Alright, you're going to copy this into your notebook as well. Comparing 1/3 and 1/2. Now, take note of where the whole number is. It is way further right or left than where the fractions are. So you know these are only a fraction of a whole number. They're not a mixed number. Let's compare 1/3 and 1/2. As you can see on the first plot, positive 1/3 and positive 1/2. Positive 1/2 is further right on the number line. Therefore, 1/2 is a larger amount. Kind of like a pizza if you were to cut it into thirds versus cut it in half and eat it. Honestly, by the time we eat lunch at Glenview during class, I prefer half pizza than 1/3 of a pizza. Okay? However, when you move on to the opposite numbers, when you move on to the negative numbers, you can see that when you plot them on the number line, that -1/2 is actually to the left of -1/3. So the two negative rational numbers are opposite of the two positive numbers, and therefore the -1/2 is less than -1/3. Last video, or last section, we talked about the further left the number, the smaller the number is going to be, just like for integers. The further left, the smaller it will be. Okay? Go ahead and copy this information into your notebook and push play whenever you feel like you got it all down. Alright, here's another problem that you're going to work into your workbook. Most of you guys know the answer to this problem just by looking at it, but in case you don't, whenever you are comparing a fraction and a decimal, the easiest way to compare the two is to turn that fraction into a decimal. So -1/2, whoops, sorry, go back. -1/2 can be written into a division problem. Your denominator is your divisor, and your numerator is your dividend. We know that 2 cannot go into 1 evenly, but it can go into 10 5 times, which gives us 10 and a remainder of 0. So, our answer, when we are turning -1/2 into a decimal, is -0.5. We're comparing 0.5 and 0.5, and I hope at this point you can see that they're equal. Okay? I hope you're paying attention really closely because the next one you're going to be doing on your own. Go ahead and copy this part down so that way you have a really good reference to go back to when you get on your digits and you get kind of stuck. You can just kind of look back in your notebook and see what you did. Alright. I'll go ahead and skip 2. Nope, I didn't. We're good. Okay. Here's another example that I want you to copy down. Everything that has the white background, copy it down. The absolute value of any rational number is the distance from 0. That's the same as the absolute value of any integer. Okay? The only difference is that the rational numbers include fractions and decimals and percents. Okay? So, we know that the absolute value of a number is simply how far from 0 it is. So, the absolute value of -1 2/3 is 1 2/3. Talks about distance, talks about how far away, okay, or how deep. Take a mental picture of what you see up here. That's all going to go into your notebook. Push play when you get everything done. Alright, so I'm going to work out the first two with you so you have a really good example. And then I want you to work out the last four by yourself. When you feel like you have your answer, I want you to push play on the video and and see if your answer matches up. So let's do A together. We're comparing the absolute value of 1 and 25/100ths to the absolute value of 1 1/2. Well, again, whenever I'm comparing decimals and fractions, I like to turn that fraction into a decimal. It would still be the same amount, it's just written in a different form. So we know that 1 is going to stay the same. Okay? And we know that our denominator is our dividend. So it's going to be 2 divided by 1. We did this a minute ago. 2 cannot go into 1 evenly, but it can go into 10 5 times, which gives us 2. Okay? Our numerator is always our answer. So now we're comparing 1 and 25/100ths to 1 and 5/10ths. All right, and in the last unit we talked about how if you're comparing two decimal numbers, you look at the number that is the closest to the decimal points. Well, we have both 1s as our whole number. But if you go to the decimal part of the number, you have a 2 as your first number and a 5 as your first number. So those are the values you're going to compare. 5, I hope you know, is larger than 2 if they're both positive numbers. So 1 1/2 is larger than 1 and 25/100ths. Let's move on to B. We're comparing the absolute value of -1/3 and the absolute value of -0 and 67/100ths. Well, we know that this is the same as 0 and 67/100ths and 1/3 because the absolute value is only talking about distance. Okay? Again, when I'm comparing a whole number, a decimal and a fraction, I like to turn that fraction into a decimal. So I know that my denominator is going to be my divisor. 3 goes into 1. 0 times. 3 goes into 10 3 times, which is 9. And this is going to keep on going on forever and ever and ever because you're not going to get smaller than the 9. So 1/3 written into a decimal form is 0 and 33/100ths. We're comparing that to 0 and 67/100ths. Again, since they're both positive numbers, look at the number that is closest to the decimal place. If that number that's close to the decimal place is both positive and larger, then that decimal is going to be larger. Okay? You're also going to keep in consideration about where on the number line would that be. And we're going to go over that a little bit more later. Do the rest of these problems by yourself, and then in about a minute or so, when you feel like you got it, push play, and let's see if you got the correct answers. All right? All right, so here are the answers for A, B, C. We know that the answer for A was that 1 1/2 was larger, and the answer for B was 0 and 67/100ths was larger. Now you're going to compare C. Your answer is 1 1/2 is larger. 1 1/2 and the absolute value of -1 1/2 are equal. Alright, so for answer D, we're comparing a mixed number and a decimal with each other. And when I'm comparing a mixed number and decimal, sometimes it's easier to turn it back into them both into mixed numbers instead of having 2 decimal places, especially if you're going to find those places on a number line. We know that when we are saying 1.8, we say it like 1 8/10. Okay? When you look at that mixed number, you can see the 8 and the 10. You can realize that 8 and 10 are both divisible by 2. So 8 divided by 2 will give you 4. And 10 divided by 2 will give you 5. So the 1 8/10 will be reduced to 1 4/5. Okay? Now, we need to create a number line and plot 1 1/2 versus 1 4/5. So I'm going to go ahead and do that. The 0 is kind of in the center. Then we have 1. Okay, and then we have 2 over here somewhere. Alright, and our denominator that is larger is 5. So I'm going to go ahead and make 5 parts. To represent my whole, because there's 1, 2, 3, 4, 5 spaces between 0 and 1. Okay? So if I plot 1 1/2, I would go past the 1. Change my color. I would go past the 1, and then I would go halfway to 2. Well, halfway for this, since it has 5 spaces, is going to be between 2 points. Alright? So 1 1/2 is about right there. Now we have to do 1 4/5. We know that we have to pass the 1, so we did earlier. But now we got to find 4/5. So 1, 2, 3, 4. On a number line, we talked about this before. If the space or the dot is further right on a horizontal number line, the value is greater. Okay? You can do the same thing when finding the answer for E and F, but we don't really have time. We got to move on to the rest of the video. Alright? So what you can answer this problem in your workbook is the absolute value of negative 2/3 greater than, less than, equal to, or cannot be determined when comparing it to the absolute value of negative 1/2. Alright, think about what absolute value means and then compare your numbers. Again, it says answers in your workbook, so copy down everything you see. Alright, so you don't have to write this in your notebook. Ignore this note above because I want you to just pay attention to this part. The next part we're going to copy down, but I want you just to listen for this one. Let's talk about it first. We're going to compare the elevation of a bottlenose dolphin's regular dive for food to the deepest trained dive ever recorded for a bottlenose dolphin. Then we're going to explain the meaning of 0 on this number line and the meaning of the rational numbers we're comparing. Alright, so we're going to be comparing 0, or negative 0, excuse me, let me kind of put my pen on, negative 0 and 547 thousandths of a kilometer. If we're talking about depth or length or distance, it's going to be the absolute value, which ends up being a positive number, 0 and 547 thousandths of a kilometer. Alright? I want you to look at that and then look at your other depth. That is 0 and 45 thousandths. What's the difference? All you have to do is run up your decimals and subtract. Okay? 7 minus 5 is 2. And as you can see, the difference is 502 thousandths of a kilometer. Alright, I want you to go ahead and copy this right here into your notebook. This is a little bit of a better example. Compare the absolute value, yada yada. So take a picture of what you see in the white, and I want you to copy all of that down. Okay? Pause the video so you have time. Alright, so here's your answer to comparing those two numbers. And I want you to complete your closing check before you move on. Good luck on your digits, and I hope you have a wonderful afternoon.